Thank you for the introduction. I'm Masafumi Oizumi from Araya. Today I'll talk about integrated information theory, but my focus today is how to build a mathematical theory of consciousness in general. Then let's start. So there are many theories of consciousness. For example, global workspace theory, higher order thought theory, recurrent processing theory, and recently predictive coding theory, and then integrated information theory. But we, at least I, do not exactly know how these theories are different, or what kind of experiments would differentiate the predictions of the theories. So there are not much interaction between the theories. So I think we need a common framework or guidance based on which our theory of consciousness should be built. So this kind of framework will be useful for us to improve the existing theories or clarify their differences. So I believe this kind of framework will advance the sort of mutual understanding between the theories and advance the consciousness researches. So I think I want to propose a common framework, but this framework is basically comes from IIT. So I'll explain today IIT for introducing a common framework for the theory of consciousness. So what is IIT? This is just a brief history of integrated information theory, IIT. So IIT was proposed by Giulio Tononi in the University of Wisconsin, and it has been developed over a decade since the first publication in 2004. The first version of this theory is now called IIT 1.0, and the next one IIT 2.0, and then the latest one is called IIT 3.0. And I'm the first author of this paper. I used to be a postdoc in his lab, and I intensely discussed IIT with him, and I kind of fully understand what IIT tries to do. But just by reading these papers, probably people will not understand that real meaning or real intentions of the theory. So I try to convey this sort of real intention of the theory or essence of this theory. So in one sentence, IIT is an attempt to mathematically quantify the quantity, the level, and the quality of consciousness from the viewpoint of information. But this theory, of course, has not been established yet because it has been continuously developing. And the current stage is like a newborn baby. So there are, and also experimental validations has not been successful, has not been yet satisfactorily done so far. So there are many potential weaknesses in the theory, but I think IIT offers useful insights for how we should build a theory of consciousness, in particular, our mathematical theory of consciousness. So the aims of this tutorial is the first of all, think together how we should develop a theory of consciousness. That's our main aim. And I'll explain IIT, but the goal is not to make you understand exactly IIT as it is, but rather to propose a common framework for building a theory of consciousness. So today I'll only consider IIT, but in future we should discuss the other theories by using the same framework and clarify the differences. I think this is a very important step for consciousness researchers. So I'll try to do this by myself, but if you are a specialist in some of theories, please feel free to do it by yourself too, and let me know how you characterize the theories within this framework. Okay, this is the summary of how to build a mathematical theory of consciousness. So I'll, of course, explain in details each step by using IIT as an example. So the first step, or step 0, is to specify problems to solve. This determines the scope of the theory. And the next step, specify essential properties of consciousness. This actually corresponds to the definition of consciousness. And step 2 is to derive hypotheses from the essential properties of consciousness. And the third step, describe the hypothesis with mathematics. That's, I think, the sort of unique point in IIT. So, because IIT is written in mathematics, I think the meaning is sort of uniquely determined by the math. So we can sort of fairly, openly discuss the, strengthness or weakness, and we can sort of openly improve the theories because of mathematics. That's, I think, importance of, maths, using maths in theory, in a theory. And the final step, test the hypothesis in experiments. That's the, summary of today's talk. So I'll, go into the details step by step. Okay. Then, by the way, you can ask questions during this talk anytime. So please feel free to interrupt me anytime you want. So let's move on to the step 0, which is to specify problems to solve. So this is just a specific example of IIT. And the first problem is about quantity, level of consciousness. So what determines to what extent a system has consciousness? So specific questions will be like, why do we lose consciousness during our dreamless sleep? Or are other animals or even AI are conscious or not? And to what extent? That's our first problem IIT is trying to solve. The second problem is about quality or content of consciousness. What determines what kind of consciousness our system has? By the way, so I forgot to explain the meaning of system. System is anything, like it could be brain, and it could be PC, computer, or anything is the object for IIT. So IIT is really general theory. It's not just about human or consciousness or biological things. It can deal with some artificial systems as well. So the word system is very general word here. And the second problem is about quality or content of consciousness, or what determines what kind of consciousness our system has. For example, why do colors look the way they do and different from the way music sounds? Or is the redness of red I feel different from that other people feel, or something like this. So this is the second problem. And the third problem is sometimes missed if you just read the IIT papers, because I think this point has not been emphasized much. So the third problem is about the places of consciousness. What determines where consciousness resides in the system? So where does consciousness reside in our brain, or how many consciousness exist in split brain? So these are the actually whole thing IIT tries to solve. In other words, IIT doesn't try to solve other things than these things. Okay? So this step determines the scope of the theory. So if you are interested in other problems in consciousness, IIT is not the one that tries to solve this. So you need to different theory for this. So by specifying the problems, we can sort of discuss the differences here, I think, between different theories. Sometimes I actually cannot understand what the theory tries to solve, or the scope, the exact scope of the theory. So I think that we should clearly describe the problems. And the important point here is that IIT does not try to directly solve so-called hard problem of consciousness. So the hard problem of consciousness is basically hard problem of consciousness starts from the brain. So by looking at the brain, we would never know why this brain generates this subjective experience. So we cannot go in this direction. So IIT's direction is sort of reversed. So IIT actually starts from the subjective experience itself. IIT starts by observing our own subjective experience and characterizing the essences or essential properties of our subjective experience. And then IIT, derives hypotheses that about the conditions where this kind of consciousness can be generated. That's the way of logic in IIT. So IIT moves to our next step. That's step one. Specify essential properties of consciousness from the observation of our own consciousness. That's a phenomenology. That's called phenomenology. And IIT specifies the essential properties of consciousness are basically four. There could be other things, but so far IIT just nails down the essential properties are only four. So first property is information, and the second integration, and the exclusion, and the composition. I'll explain the details later, but I think this step corresponds to how the theory thinks about how the theory characterizes the consciousness. So in other words, it's a theory's sort of definition of consciousness. And of course, this definition could be different among many different theories. So I think this step, again, is very important. So how does IIT think about consciousness? The first essential property of consciousness is information. So consciousness is informative. It is one out of many alternative experiences. What does that mean? So we could have many potential, experiences, but our experience at a particular time, is just one. For example, I should use this. Let's say this. So when we experience this, we sort of exclude other possibilities, and we can feel a particular experience. For example, this is different from this, or different from this, or different from that, and so on. So in that sense, we can differentiate our many other possible experiences. In this sense, consciousness is informative. That's first essential property of consciousness, IIT thinks. The second essential property of consciousness is integration. So consciousness is integrated. For example, you cannot experience colors independent of shapes, or the left half of the visual field of or the left half of the visual field of a view independently of the right half. So as you know, for example, the right half of the visual field goes to the left brain, and the left half of the visual field goes to the right brain. But our experience is the whole thing, combining these information, and we cannot, no matter how hard we try, we cannot, experience only the left or only the right. That's the meaning of integration. So the third one is the most difficult one to understand, and probably the most controversial one. It is not that evident at all, I think. But the third property of consciousness is exclusion. So consciousness is exclusive. For example, experience without color, or that with only the left half of the visual field, not simultaneously exist. For example, when I experience this without color, or only the left, do not exist in this world. What exists is only this. So we believe that our brain, of course, generates this consciousness. But which means that this brain can generate, for example, this without color, potentially, right? In terms of the ability, right? If this can generate this can of course generate same experience with less content, for example, without color, or for example, without the light half. But somehow, these potential experiences are excluded in this world. And only this seems to exist. That's the meaning of exclusion. And also, there could be the experience with more content, like this with other things. because the brain actually processes much information, and also much more information than this, right? But what we experience subjectively is only this.
Excuse me. In a way, it is a kind of integration. So, what exactly is the difference between integration and exclusion?
Exclusion means that there are potentially many other experiences, right? But what exists, or what seems to exist, is just only the particular one.
In a way, it is about unity of consciousness. So,
unity is about the previous one, right? Like
it's a spatial unity.
Spatial unity, and of course that we can think of, for example, that unifying different modalities or different modality information. Mm-hmm. These are other examples of integration. But this thing is talking about totally different things. Mm-hmm. And also, maybe this example is much more easier, yes, for example, to understand what I meant. Like, in our brain, we tend to think only one consciousness exists that combines the left and the right brain. And we tend to think there are no two independent consciousness in the left or right brain. Right. But potentially, right brain or the left brain can generate their own consciousness. Because that we know that in the split brain patient, where corpus callosum is cut, it seems like two independent consciousness exist in each hemisphere. So it just depends on the strength of connections, strength of corpus callosum that connects the left and right brain. And what happens in the normal brain is that consciousness in the left or right brain is excluded for some reason. And only the one sort of unified consciousness exists. Yoshida-san, does it answer your question? Or
okay,
you can
thank you for your elaboration.
And also that we can think other examples, like two people are talking. So in this case, two brains are talking, right? So we can think of the whole system, like consisting of the two brains. What happens here is that two independent consciousness exist, even though these two brains are weakly connected, right? By the, for example, conversation, right? But so the totally different thing, opposite thing, happens in this case. And we usually think one unifying, consciousness does not exist in this two-brain system, right? So in this case, the whole brain, so the two brains consciousness is excluded, right? So this kind of exclusion happens. Thus, IIT, considers this is the third, principle or third essential property of consciousness. Yeah, of course.
So you said that the methodology of IIT is starting from phenomenology.
Yeah.
This property doesn't look like deriving from phenomenological observation.
Yeah. So it's a little bit mixed up with observation of some phenomenology and sort of actual physical substrates. But only from the phenomenology we can say something like this, right?
but I'm just wondering if I can ask more about it. Whether, the example that you just gave in the first slide,
Yeah.
namely the one that is related with the phenomenology itself, not like this two brains or split brain
Yeah.
example, is just the same level of the description in a sense that the one that is related to brains, right? Because if I'm thinking about my own phenomenology, I of course cannot imagine the situation when I've got two brains, right, or split a brain into two separate stream of consciousness. But on the other hand, if I'm thinking about two distinct phenomenal qualities, that one is weaker than the other, for example, like the one got like integrated color and I don't know, shape, and the other not. I think it's possible. Is that the thing that you observe, for example, in the context of the subliminal perception?
Yeah.
It's just not existing in one single moment, but it possibly could be generated.
Yeah, could be generated in the other moments, of course. But at a particular moment, it seems only one exists. That's a sort of observation.
Okay, so it's about the single moment.
Exactly, about the single moment, yeah. Go ahead, yeah.
Can you explain again about the exclusion? Because I always have difficulty to tell the exact difference between exclusion and information.
Yeah. So where I should start, like it's again this is a good point. I sort of mixed up the phenomenology and also this physical substrates, and but I think that we need to think about also the physical substrates to understand what this exclusion means, or what the importance of this property. And so let me explain in this way. So our brain, right? Our brain, processes much information from the external world, and then this brain generates this consciousness. But this consciousness is sort of the subsets of information the brain is processing, right? And also, if this brain can generate this consciousness, potentially the same brain can generate the experience with less content, like this same one without current, or the same one without a light power, something like this. Potentially, this brain can generate these things. But at the single moment, at the particular moment, only this exists. And the other possibilities seem to be excluded. It's difficult to understand. Or the other example is like this, right?
Just to go back on this.
Go back this.
So it seems, on the contrary, it would be much more intuitive to say that instead of having just one single experience, we have a sum of all the other experiences. That is, I have at the same time the right half, the left half, without color, with color, whatever. All these happen at the same time. And this is what makes it the experience, the global experience that I have. So I don't see why you would even have to consider to exclude these, because they are components of the main experience. You don't need to exclude them.
Yeah, it's the other direction to go, maybe.
I think it's about compositionality.
Probably. Yeah, I think it could be related to compositionality. But so I think that what you are saying that, for example, in this case, you want to think like simultaneously this one consciousness exists
as well as two independent consciousness exist in the left and right brain. That's what we want to assure.
Why would you want to say independent?
Use your microphone. Use your microphone.
So
What I'm talking about is two dependent consciousnesses make one united consciousness. I'm not saying they are independent. They are dependent.
Dependent may be the not appropriate words, but what I meant here is that it's their subjective entity. Sorry, that it's their entity that can subjectively perceive, for example, the visual things or many other external stimuli. For example, the left brain can subjectively perceive only the experience, in here, generated in here. Do you think so?
So in split brain situation, or if
No,
you
not
consider
only
two
split,
people, yeah, they are independent, and this I completely agree.
Oh, you mean this?
If the brain is whole,
Yeah.
and you only consider one brain and not two, one brain.
One brain is one brain. I don't know.
Then whatever composes the experience is a set
Yeah, of
of
course. Yeah.
things, right? So I think
Yeah.
I'd like to see how you explain the composition.
That's
because
I can go back to you after I explain compositionality. I agree that these things are dependent, and these things are, the elements that can, these elements are, constitute the whole brain sort of experience. For example, that of course the left brain and the right brain can contribute to generating the whole brain's consciousness. But we are talking about the sort of the entity that can have subjective experience, right? For example, only the visual region or visual areas can have consciousness, or only for example that if we allow this situation like left and right brain also can have consciousness, then we can extend this to the other sort of micro consciousness like visual areas consciousness, or auditory areas consciousness, or only 2 neurons or only 3 neurons consciousness, or anything any kind of consciousness could exist if you allow this situation.
I would like to ask for a clarification.
Yeah.
So the essential properties of consciousness, does it mean what is distinguishing it from unconsciousness? So unconsciousness wouldn't have these properties?
Unconsciousness. You mean, for example, in this case, only the left or only the right brain are sort of unconscious, and only the whole thing is conscious. In a sense.
I was rather asking about, for example, the integration properties.
Yeah.
So the shape and color perception is integrated together. That would only happen once we are conscious of the object, and when we are unconscious, it's not integrated because it's a property of consciousness. Do I understand it correctly?
I actually don't fully understand what you meant. Your question is that integration is always necessary for being consciousness or something like this?
So I'm basically asking if it then does it mean that when we are unconscious, we don't have integrated?
That's next step actually. So I've just specify the potential essential properties, and that's a kind of hypothesis. So the next step.
Okay, so this is not, because I'm just basically tapping to some experiments in working memory where it is argued, and there are evidence on both sides whether the stored information
Yeah.
is integrated or
Yeah.
whether it's not.
Yeah.
So
Yeah,
what's-
that's IIT's hypothesis. Yeah, so you are right in that sense. But what I'm talking here is just describing the essential properties from the observation of our consciousness phenomenology. And at this step, IIT doesn't hypothesize anything so far. This is just properties, essential properties.
Thank you.
Can I ask something?
Yes.
Okay.
Yes.
Yeah. So, is it correct to understand what you said about exclusion in
Yeah.
this way?
Yeah.
So, we have when we have a whole scene, or
Yeah.
whole visual scene,
Yeah.
only the left half of
Yeah.
this visual scene
Yeah.
is part of the whole scene.
Yeah.
But we cannot simultaneously
Yeah.
have consciousness
Yeah.
of left half
Yes.
and the whole
Yeah.
scene.
Yeah.
So, of course, the left half is a part of the
Yes.
scene, but it is not possible that we have two consciousnesses at the same time.
Exactly. That's
Yeah.
what exclusion
Yeah,
means.
okay.
Yeah.
So if that is what exclusion means, does it
Yeah.
mean that if you do have two simultaneous experiences, there are two distinct systems?
Uh-huh. So,
Is that true?
so what does it mean? I have only, I have only experienced one thing, right? I cannot experience the other.
Sure, but if you did, does that
If
then
you
mean that
did-
there are two simultaneous systems operating in you?
Of course, yeah. This is a split brain case, right? Right. If these two systems are cut, completely separated, two independent consciousness exist, right?
Okay,
Yeah.
so that would coincide with a lot of philosophies of personal
Exactly.
identity,
Yeah.
satisfactorily. So
Yeah,
like
yeah.
if there were
Yeah.
two simultaneous streams of
Exactly,
consciousness,
yeah.
then there would in fact have to be
Yeah,
two
yeah.
systems that seems-
Yeah, I mean, in one system or in one brain, there could be multiple consciousnesses. That's but for simplicity, I said that there is only one consciousness in the brain. But according to IIT, there could be many, actually. So there should be one sort of big consciousness, but there could be other consciousness as well. But not everything, every possibility exists. Like only some of consciousness exists, but the other things are excluded. That's the point of this principle property. So maybe I should move on to the next one. So this is the final one. So the fourth essential property of consciousness is composition. So consciousness is structured. So for example, within one experience, one can distinguish a book, a blue color, or blue book on the left side, a blue book on the left, and so on. So in IIT, these things are called sort of concepts, and there are combination of concepts as like a blue book on the left or so on, and there is sort of structure in our experience. So maybe this relates to the previous question, or no? Because for example, left visual field, of course, the constitute of our consciousness. It's one element, of course. That's what you mean?
You just need one either composition or exclusion, but basically I don't see why if you use them this way they are useful at all. So maybe it's better to see what else you could tell about this.
Okay.
I don't see the point here.
You don't see the point here. Okay.
So maybe that, let me explain this in this way. For example, this is sort of an example, consciousness without compositionality or without structures. So in this case, that these things are, these four things are actually different, but we cannot see like a relationship of similarity between any two, like this and that are more similar, or this and that are more different than this and that, or something like this. So without structures, we basically all experiences are equal.
Information, you were saying the first is information.
Yeah.
So because you have access to the information, it's enough.
Yeah.
You don't need this to talk about this composition anymore, because the information tells you that the experience is different from another.
Yeah.
You really don't need the composition.
Yeah, information is talking about sort of, we can differentiate many experiences, right? And also, but this doesn't talk about the similarity between experiences, right? So I introducing where the compositionality relates to the how similar two experiences are, or how dissimilar two experiences are. For example, that we again can differentiate all of four pictures, of course, but you can see that, for example, this and that are probably similar, right? More similar than, for example, this and that, because of there is a sort of mountain and trees. So if experience is a structure, there is a relationship of similarity between different experiences. That's about compositionality of experiences. So okay, so that's step one. So in step one, from the observation of our consciousness, IIT specifies the four essential properties of consciousness, which are information, integration, and exclusion, and composition. By the way, so the composition relates to also quality of consciousness. So information itself doesn't talk about the quality. And with this composition property, IIT sort of characterizes the quality of consciousness. But anyway, so these four things are essential properties of consciousness, IIT thinks. So there could be other possibilities. And other theories could think, different things are essential properties, or exclusion is not right, or so on. But the important point here is that please, clarify the definition. So this again corresponds to the sort of definition of consciousness, the theory's definition of consciousness. So IIT thinks these are the consciousness. These characterize consciousness. And then next step is that deriving the hypothesis from the essential properties of consciousness. So this answers the question from you. So from these essential properties of consciousness, these are the hypotheses. First one is that, for example, for consciousness being generated, a system must generate information. And also, a system must integrate information. And to realize this exclusion property, only a system having locally maximal integrated information can generate consciousness. I'll explain the meaning later. And also about the quality of consciousness. So informational structure of a system corresponds to the quality of consciousness. these are just hypotheses. So these hypotheses need to be tested. But we basically do not test these essential properties themselves.
Can I ask one clarification question? I think I am going back to one earlier question about unconsciousness.
Okay.
So I wonder whether it's part of your claim that unconscious cognitive processes do not have those properties. Because we can think about, well, we can think about unconscious processes conveying some information. We can think about unconscious processes integrating information. We can think about unconscious processing, like can have exclusion kind of structure. So is that your claim that no unconscious process does not have these things?
Okay. That's true. Yeah. So if you prove that, for example, that the unconscious system actually generates information and integrated information, then this is proof that IIT is wrong. IIT is seriously wrong. So we need to test these hypotheses in experiments. Please.
So actually now composition makes sense with the fact that it characterizes the quality. I think this is fine.
This is fine.
Yeah. But here, I'd like to understand where the hypotheses come from, especially the third. Yeah,
Third one.
Third.
Third one. Okay, this is the most sort of controversial, and this is sort of jump, really big jump from this property. And because of why only the maximal one exists, there is of course no explanation. And actually, I don't know how Giulio Tononi, for example, come up with this idea. But the important thing here is that we need some explanation. We need some theory to realize this kind of exclusion principle. And this is maybe one way to explain the, for example, split brain cases or so on and so on. So, yeah, this is again just a hypothesis, and probably this is the most really difficult one, and also the most interesting one for me.
May I ask a basic question?
Yeah.
So in the history of IIT from 2004,
Yeah.
are there any were there any updates on this part? I mean, the essential properties.
What part? Which part?
Essential properties.
Essential properties. Yeah. I think that there probably exclusion was not discussed in the first version. As far as I remember. Do you remember that? Actually, I don't remember. So, maybe, but IIT 3.0, it clearly describes this is one of essential properties. Now, sorry, maybe it was there already, but IIT 3.0 actually clarifies this kind of framework. Like let's start from phenomenology and derive a hypothesis and so on and so on. So this is the framework I'm going to explain today is first clarified in IIT 3.0 as far as I know.
Thank you.
But the essential things were probably already there in the first version. And also the update is about mathematical quantification of information, integrated information, and so on. That's definitely update from IIT 1.0 to IIT 3.0.
Can I ask another question?
Yeah.
So those four hypotheses captured, consciousness in a general way. I wonder if you think about sensory experiences, there can be different kinds of sensory experiences, perceptual perceptions, imaginings, or episodic memories, which
probably false one.
Yeah. So there are differences in terms of quality.
Exactly.
So do you think that the theory captured, if we want to capture the differences among different kinds of, so it has to come in the fourth kind?
Fourth one. Yeah.
Okay, so different informational structures.
Exactly. Yeah. So quality is about false hypothesis.
One more question.
Yeah.
What is one system? How do you say that this is one system?
This is very good question. So we determine what is a system or what is a conscious system from based on theoretical prediction. Like as it claims, only a system having locally maximal integrated information can generate consciousness. So this is the only system that can generate consciousness. So let's think about the whole loop, for example. So we calculate integrated information in this loop. So I can calculate integrated information considering all of us. And also we can calculate here, only here, or we can calculate this and that. And all possibilities need to be considered. And then only the locally maximal one exists as a conscious entity. And we can say this is the system. This is the system. And by the way, here, a system can be conscious or unconscious. Anything can be a system. But my point here is that in IIT, we consider all of possible systems, all combinations of systems or something. Does it make sense? Maybe I can explain this in later slides as well. But anyway, so as you can see, or as there are many questions in here, these hypotheses are not, of course, clarified with only these sentences. So we need, I think, mathematics here. Okay? So for example, what is information? Or what is integrated information? Or what is locally maximal? By the way, integration information is sometimes called phi. And what is locally maximal phi? Or what is informational structure? These things are very ambiguous and are very not well defined, even only by these words or sentences. So to avoid ambiguity, we need to describe them by mathematics, by using math. That's the third step. And we can discuss the meaning or if there is a flaw or weakness, we can fairly and openly discuss based on math. That's, I think, the importance of mathematics here. So I'll explain the step 2 and the step 3 in the followings. So there again, that the first essential property is information. So consciousness is informative, and from this essential property, the first hypothesis is derived. For generating consciousness, a system must generate information. That's a very simple one. So let's consider this example, like a photodiode example. Like here we consider just a single photodiode, and this single photodiode can differentiate light off and on. So, but if we present for example, the blue color or blue light or green light to this photodiode cannot discriminate like blue or green, these are categorized as on, just right on. Right. So in this case, in this sense, that this photodiode, of course, generates just a little bit of information, but of course, not much. And in contrast, that our brain can differentiate many other things, like not only for colors, but these textures, and also these things are all look different for us. So in this sense, our brain generates much more information than just a single photodiode. That's a very big difference between us and a single photodiode. So this means that if a single photodiode can generate a really small consciousness, it is totally different from our consciousness. So the next one is that integration. So the essential problem is again that the consciousness is integrated. So here a hypothesis is that the system must integrate information. So the question here is that can digital camera be conscious of what it sees? So I say that a single photodiode can potentially generate really tiny information, but if you accumulate much more photodiodes, as in digital camera, like 1 million photodiodes, then we can think that it can generate really huge amount of information. So we can arbitrarily increase the amount of information if you add more. But what's the difference between digital camera and the brain? Of course, that the answer is that in the digital camera, these information are not integrated because there is no connections between the photodiodes. So these photodiodes independently process information, and these tiny amount of information only exists in each photodiode, and these tiny information are not accumulated in the digital camera, in this digital camera.
I guess we need a definition of integration here.
Yeah.
So if you look at neurons, they work independently, right, at first, and then because of further connections, let's say they integrate somewhere, although we need to define integration.
Exactly. Yeah.
So here you take a picture with your digital camera, and all the photodiodes are independent, but the resulting file that you get from taking a photo is integrated, right? So you have a file that puts all the information together. It's integrated.
Yeah, of course.
So that's why we really need a definition.
Of course, that I'll explain the definition of integration later, but the picture looks like a picture contains a lot of information. But when our brain sees the picture, we can extract a lot of information. But this is our brain job. This is not the job of our digital camera. Digital camera cannot, generate this picture information. This information sort of, in a way, doesn't exist if we do not see.
So my camera has something really amazing. It can detect faces.
I don't consider that case, actually. Here, I consider simple digital camera, where there is no face detection, or there is no any kind of fantastic function. But anyway, so it's a very good point, because I don't explain the meaning of information and integration, this claim is very ambiguous. But anyway, so there is a clear, again, the essential difference here is that in the digital camera, there is no integration, but in the brain, there is integration. So that's a huge difference, and that differentiates whether the system is conscious or not. And also that the IIT's hypothesis here is that integrated information, that's the amount of information integrated in the system, corresponds to the quantity or level of consciousness. So let me explain just a little bit about the mathematics. Actually, that my slides today do not contain much of mathematics, but this is probably the only one that contains mathematics. Or two slides from here probably contain mathematics. That's the only ones. And so how we should quantify information? So first, let me explain the usual conventional, sort of quantification of information. So when we think of information in the brain, we sometimes consider the information between external stimuli and neural responses. So neuroscience actually deal with this information mainly. And for example, that this information, like how much information about the stimuli are there in the brain, can be answered by quantifying the mutual information between stimuli and the neural responses. So the mutual information is quantifies that how much uncertainty of stimuli are reduced by, for example, observing neural responses. So if we can, let's say that decode the stimuli from neural responses, we say this has a lot of information about the stimuli. So this amount can be quantified, so-called mutual information. But this mutual information is only for some external observer. And for example, we call it extrinsic information. Actually, if we quantify information in this way, a digital camera has as much information as us, right? If we arbitrarily increase the number of photodiodes in digital camera, for example. Because the mutual information between the response in digital camera and the stimuli are also very huge, right? So this extrinsic information is basically irrelevant to consciousness or subjective experiences. So we need to quantify information in a different way. So which is called intrinsic information. So IIT tries to quantify our information for a system itself. The information relevant to consciousness must be observer-independent, intrinsic property of the system. And this kind of notion of information is called intrinsic information. So here again, that we do not quantify the information between the neural responses and the external stimuli. We only look at the neural responses or the system, only the system we are looking at, like this. This is, by the way, that some neural networks, and these circles just are cells, neurons, and these black and white represent that whether this is firing or silent. And then, given this, given this state at time t, the state of the system at time t, what we ask here is that what's the potential past state. What's the likely past state based on this, and based on the present state, and based on the connections between neurons. So this kind of information is quantified by mutual information between the past state, this is the past state, and the present state of the system. So we quantify how much the uncertainty of the past state can be reduced by observing the present state. This is IIT's way of quantifying information here. Then next step is difficult, and again, this is the only, this is the last step, which contains mathematics, by the way. Yeah. Okay. So how we can quantify, integrate the information? This is again that very developing field, how we quantify integrated information. But I'll explain the one way to quantify integrated information. So when we do quantify integrated information, we need to cut the system into two subsystems. For example, we cut here, then cut means that not the physical actual cut. Actually, this cut is sort of a mathematical operation in probability theory. So we consider again that some network dynamics of the system. So this dynamics is described by, the xy means that the xt minus tau and the xt, meaning that the relationship between the past and the present. So we consider that some joint probability distribution of past state and the present state. And this joint probability distribution characterizes the network dynamics of the system. So we have original network dynamics here, and we cut the system, meaning that cut the connections between the two subsystems. And then we make disconnected or cut probability distribution. That's different from P, because we cut the connection. And the difference or information loss caused by these connections are phi, the definition of phi. How much information is lost by this disconnection? Or how much difference is there between P and Q? That's the way of quantifying integrated information. So if there is no connection at all, there is no causal relationships between two systems, integrated information is zero. So integrated information quantifies that this kind of causality or causal inferences between inside the system. Yeah.
Now, I guess this is the definition.
Yeah, definition.
So, okay.
Yes.
So now, if we go back to the camera that has a function for detecting faces.
Yeah.
Let's say you could have a cut between the collection of the image and the detection of the face, right? Between the two functions.
Yeah.
So how does the mathematics apply there? So because you do this cut between the function for face recognition and the image production, you lose information, right?
Yeah. That's in that case, the integrated information is non-zero. Yeah.
Okay. So you're saying if the camera detects faces, then phi is above zero.
Yeah, there is
this
integration. Yeah.
Okay.
But this is actually based on second IIT 2.0 version of phi, definition of phi. But in IIT 3.0, we also introduced another definition of phi, so which I don't explain in details. But in that case, the information is quantified in 2 ways, like how much information in the future and in the past. In the both directions, we quantify information. And then, if there is no information in one side, or in the past or in the future, we say this is no information. So there has to be information in both sides. If you require this condition, for example, that the purely feed-forward network cannot generate information, or cannot generate integrated information, for example.
Actually, in the system where you need tracking, usually you use the past detections in order to predict the position for the next position of the object. So you use past information in order to avoid false detections, and then that would count again as a positive phi, right?
Yeah. I think that it's different from that thing actually. That I'm talking. Actually, it's really difficult to explain that without any slides or something or any equation of this notion. But again, that there could be other definition of integrated information, and if you apply this definition, again, that in a simple face detection camera can generate a non-zero integrated information. But if you take the different definition of integrated information, as in IIT 3.0, for example, that a purely feed-forward network, like for example, the deep learning or deep learning type network cannot generate consciousness or cannot generate non-zero in phi. But anyway, so for here, that my point here is that today's aim of this tutorial is not to exactly explain the details of IIT. I just my intention here is that to convey the framework, convey the theoretical general framework for building a theory of consciousness. So this is just an example. So this could be, of course, wrong, and this thing needs to be tested in the future experiments. So let's just assume this is the definition of integrated information. So if you take this definition, for example, that in a simple digital camera where there is no connection between photodiodes, there is no information loss, even after connections between photodiodes are cut. So in that case, integrated information is 0. On the other hand, in the brain, there will be a lot of information loss after connections between neurons are cut. In that case, integrated information is high. That's a difference between the brain and the digital camera.
So one quick clarification question. So the case of just one, the diode case.
Yeah.
What's the integrated information? Because there's no possibility of cutting.
Yeah.
So
Exactly.
Does that mean the integrated information is very high?
Yeah.
In that case?
Actually, yeah, that's again very good question. But if you think that the single photodiode is one element, we cannot define integrated information. Integrated information is defined when there are at least two elements, right? But when you want to quantify single photodiode, maybe you need to look more, smaller elements inside of the photodiode, and then you can calculate in more microscopic level. You can calculate some phi inside the photodiode. But if you think macro system like a single photodiode is one element, then integrated information actually cannot calculate anything in that scale. Okay.
In a way, a system assume it is composed of at least more than two.
More than one, yeah. So let's move on to next step. This is a little bit detailed, but how we should partition system. So I said that to quantify integrated information, we need to cut in some way. So how we should cut, or how we should partition system. So IIT specifically considers only one particular partition, which is minimum information partition. So minimum information partition is defined as a partition where the information loss is minimal, or the difference after the cut is minimal. Like when we consider this 4-element system, and 1, 2 are connected, and 3, 4 are also connected, but there is no connection between left and right. In this case, the minimum information partition is here, because if we cut here, there is no information loss and there is no integrated information, because there is no connection, there is no causal inferences between the two systems. But if you cut in this way, like this, then phi is non-zero. So the computation of phi depends on how we cut the system. But IIT considers only this is important for quantifying consciousness, because in this case, the whole system cannot generate the consciousness, Of course, only the left or only the right could generate consciousness, but the whole thing cannot generate consciousness. In that sense, phi should be 0. And to realize this property, we need to consider this minimum information partition.
So there is some degree of consciousness here.
Yeah.
So you cannot say that it is not conscious at all. Phi is 0.
Yeah.
Something like that.
Yeah. So the
why should be something not 0? Because there are some connections that you cut them, you lose information.
Yeah.
So why is it y is equal to 0?
You mean in this
I
case?
expected it to be smaller than the phi of the, I don't know, some other system that is more connected.
You mean in this case? Even this case?
Yeah.
I mean, as I said that subsystems can generate consciousness, but the whole thing cannot generate consciousness, right? As a whole.
So why is it 0?
Why is it 0? Because there is no connection. We can separate two systems, like me and you. We can separate me and you without any loss of.
Based on your definition, phi is 0. I understand that.
Yeah.
But I mean that the definition should be something that leads to some value for this system, not just 0.
Why?
Because there is some degree of connection.
Yeah, of course. Again, the important thing here is that IIT computes the phi in the whole system, and also IIT computes phi in each subsystem, and then attribute some positive value in each subsystem. Okay. So in this case, phi is non-zero here and here, and the two systems exist, or two conscious systems exist. That's IIT's answer for analyzing this system. But the whole thing is not conscious. Yeah. But anyway, so again, IIT's prediction on quality of consciousness is that integrated information quantified with minimum information partition corresponds to the quantity level of consciousness. Okay, that's but again, this is hypothesis. So we need to check this in experiments, of course. So let's move on to the third one. So consciousness is exclusive. That's a third essential property. And again, this is a very controversial and hypothesis. But only a set of elements that
generates the local maximum of integrated information, which is called complex, generates consciousness. So what does that mean? So given a system, this is a system. And then what we need to do is that compute phi in every possible subsystems, every possible subsystem. Phi here, phi here, phi here, we compute everything. Then only the maximal one, only the most integrated, only the locally most integrated system can generate consciousness. That's a hypothesis. So in this case, for example, we compute phi here, we consider phi here and there. So we check every possible subsystems. And then, for example, in this case, let's say whole system generates the maximum one. Then the complex is this. And other subsystems do not simultaneously exist as a conscious entity. But probably in another in another example, maybe complexes can be two. For example, this and that, this system and this system are simultaneously exist as a complex. That can happen. So, for example, let's consider again that two people, the case where two people are talking, for example. So this case, the meaning, the mathematical meaning of local maximum is like this. So the subsystem is a complex, subsystem S is a complex if phi of S, phi S is larger than phi of T. T is a larger, bigger set than S. And also phi in S is larger than smaller one, R. The subsystem S satisfies, if the subsystem S satisfies this condition, then we say this system, subsystem is a complex and a conscious. So for this case, IIT's hypothesis is that phi in A's brain, these are two humans, so phi in A's brain, meaning that this A's brain consists of, let's say, for simplicity, left brain and right brain, AL and AR. Then phi of AL plus AR is larger than the, for example, phi in only the left one or only the right one. And also phi of A's brain, AL plus A is larger than the phi of AL plus A plus BL plus BL, so the whole thing. Because there is a weak connection between A and B, so phi in the whole system is really, really small, right? So if these two conditions are satisfied, A's brain can generate own consciousness, and B's brain can generate own consciousness. That's a exclusion principle, right? Oh, sorry, yeah. Local, yeah. Local means this, meaning that this is not the global one. So there are many local maxima. Because if this condition satisfies, this can be complex. And there could be many subsystems that satisfy this local maximum. This is the actual example. For example, let's say if you look at the B's brain also satisfies this condition because B's whole brain, phi in the B's whole brain is larger than the phi in the B's left brain or B's right brain, and also phi in the B's brain is larger than the phi in the whole system. So this local maximum is also satisfied in B,
so you
as well as in
local here is spatial.
Exactly.
But in the hierarchy,
yeah.
you could also conceptualize the localized.
Uh-huh.
For example, at a specific level,
Sorry, I actually cannot understand. Maybe we should discuss it later or something.
Okay. What I meant is, I understand this is a point of exclusion.
Yeah, in IIT,
And,
yeah.
You said about the exclusiveness of consciousness of unity at a specific moment.
Yeah.
And I think it could be as a framework, as a possible framework,
Yeah.
which permits the parallel
Yes.
unity
Yes.
at different levels of
Yeah.
hierarchy.
Yeah.
And if you could relax the constraint about the localiness of this maximum, then there is some other framework which could also create the simultaneous possibility of the unity at different level, different description.
Yeah. Yeah.
Yeah, that's.
I see. Yeah. Yeah. I think so too. Yeah.
I'm not familiar with IIT, and I have a very naive question.
Yeah.
And after the brain, the whole brain reconnect all the network and calculate the new file. Is it still possible for the consciousness to access sub networks?
Consciousness access to some network. What does it mean?
Because the whole system is quite bottom up for me for now. And it seems like that when you see one thing, for example, if you have a half of the vision
you are talking about the whole brain in A or B?
Yeah, if you had two different input for different regions, left and right, and then you integrate it to one consciousness, can people still feel, sometimes if they want to switch, can they switch between two kind of consciousness, A and B? Even when
can you do this? I don't understand. Assumption here is that you cannot do this, like you cannot conscious of only left or only right.
Only one consciousness. Because I was like hearing the word simultaneously, so I was thinking that at one point you only have one consciousness. But for example, if you have two different views, one for left eye and one for right eye, you can't see two objects at the same time, but you can switch between them.
That's there could be other experiences at the different moments, but at the particular moment, there is only one. Right.
So you think the conscience can't access the integrated information?
Oh.
They are already integrated.
They are already integrated. I actually cannot understand.
In your model, is there any thoughts about the top-down, top to bottom access? Any assumption or model?
There is no assumption here, right? Top-down or anything. So we consider a really general system, general network. And then what we do in IIT's framework is just compute that integrate information, and then search for the local maximum, and where the IIT assumes that the consciousness exists.
Thank you.
Sorry, I cannot get your point probably. Yeah, maybe we can discuss it later. Yeah.
One quick question. Yeah. So about the comparison between the integrated information of the whole thing with the integrated information of each hemisphere.
Yeah.
So you said integrated information of the whole thing is larger than integrated information of each hemisphere. I mean, I'm just a philosopher. I'm not a brain scientist. Is that obvious?
No.
So
not obvious.
So basic idea. So as far as I understand, basic idea is that so we cut the corpus callosum and then we lose lots of information. So that shows the whole thing. The integrated information is high.
Yeah.
But we can say something similar about each hemisphere.
Exactly.
So we can
Yeah.
basically cut the
Yeah.
hemisphere into a half, and you cut the connection between frontal area
Yeah.
and back area, and you lose lots of
Exactly.
information there.
Yeah.
So I wonder whether look at that.
Yeah. This is very good point. And again, this has to be tested in experiment. That's what I mean. Because this is not obvious. Like to me, this is obvious. Like this connection is much weaker than the connection inside the brain. But this relationship is not obvious at all to me as well. So we probably need to clearly quantify this variable. And whether this hypothesis is true or not need to be tested quantitatively. That's my interest as well. Yeah. But if IIT is correct, this has to be satisfied. That's my point here. Yeah. But, I have, by the way, 25 slides, and I have only 30 minutes.
I just want to make a comment. I thought the what you are introducing here is compatible with the bottom-up and top-down question, because theoretically speaking, you can build in some information, and the information can like have top-down influence. I think theoretically speaking, if it's like an information integration idea, then some information can have like top-down influence, other information can have like bottom-up. So it's not necessarily contradictory to that sort of distinction. Yeah, because I think when people talk about bottom-up and top-down, like we think about like perception. Like it's a constructive process. You get some information from the external world. You might also have other kinds of information within the perceptual system that can play some like top-down influence.
Yeah. So, so let me move on to the next slide. So, as I said, that in the normal brain, if IIT is right, the whole brain can generate much higher phi than the left or right brain. But in split brain cases, the relationship is opposite. Like left brain and right brain can generate more phi than the whole brain. And also in the normal conversation case, that the phi in each person is larger than the phi in the whole system. So in this case, two independent consciousness exist. But if IIT is right, if there's much interactions, much influences between two brains, there should be one consciousness. There should be one unifying consciousness, and each independent consciousness will disappear. That's IIT's prediction, even for this case. Okay. So that's third property, and let's move on to the final one. Okay.
So you say about maximal integration. So whether the level of integration is measured by information, loss of information. So, but if consciousness is a maximal integration of information, then it means that consciousness is a system with no security system, right?
No security.
So if what I mean by a security system is if some accidents happen, then the system should do something to stop information, loss of information.
That's, I think, very interesting point. So large phi means that if you cut or if you damage a system, we lose a lot of information. This may not be suitable, right? As you said. So I think this relationship between the sort of robustness and high phi It's maybe interesting topic, but we don't know much about this. But a very good point, I think. Yeah. But anyway, so let's move on to the final one. So composition. So consciousness is the structure, and to characterize the quality of consciousness, we need to look at sort of aspects, many aspects of our experience, of our single experience, like blue and red and blue book. So we need to look into the part of the experience. So to quantify this kind of thing, we characterize the sort of the causal relationship inside the system from the bottom-up manner. So I don't have time to explain the whole details of this thing. So please refer to this paper if you are interested. So when we deal with 3 neuron or 3-unit system, what we do here is that we ask for that what A does for the future in the system, what A does in the past of the system. So what's the information that A brings in the system? Only A. And also we do the what does B do for the system, and what does C do for the system, and also what does AB do for a system, and what does AC, BC, and ABC is a whole system. And we characterize that the potential cause and the potential effect of A, of B, C, and from bottom-up manner, and then we can quantify the sort of probability distributions of the whole system like this, from A to ABC. Of course, you cannot understand the meaning of this exactly, but this is called informational structure. So the point here is that we consider the subsystem as well. Like in the case of ABC, you need to consider AB or AC or BC, and then we quantify the information BC generates or AC generates or something like this. And then the whole structure inside the system corresponds to the quality of consciousness. That's the fourth hypothesis. And this is just a visualization of this very complicated probability distributions. So this is sort of the space of probability distributions, and each point corresponds to one probability distribution, like A, B, B, C, or something like this. And we can sort of visualize something like this, and this sort of shape corresponds to quality. That's our fourth hypothesis. And this one is more, I think, difficult to test in experiments anyway. But as an example, what kind of network can generate consciousness with compositionality? For example, some kind of hierarchical structure is suitable for creating the concepts. And maybe I need to skip this detail, but this is sort of resembles the human or visual system. And it's like a V1 and V2, V3. And from bottom to top, the concepts are created in the middle layers by the information processing. For example, that left segment, or this is really just a toy model, so this is far from the actual one, but here in simulation, we sort of created concepts of a left segment, or not dot, and segment, or left on. And this kind of concepts can be created in this hierarchical structure. But if there's no hierarchical structure like this, for example, this network is really stupid, but what it does is that if, by the way, this is 0-1 binary unit network, and these three neurons are, inputs to this V2A neuron. And what V2A neuron is supposed to do is that discriminate 0, 0, 0. If only 0, 0, 0 input comes from the bottom, then it fires, for example. Then we prepare for example, eight neurons. Then this network potentially, this network can differentiate for 8 binary inputs by using 8 units in this case. And from the outside point of view, maybe this hierarchical structure network and this simple one-layer network do the same job from the outside point of view. But inside, there are concepts in this network, but there are no concepts, meaning that all inputs are equally solid processed. Okay, so this is the end of the IIT part. So here is a summary of IIT. So IIT first specifies the essential properties of consciousness from phenomenology, observation of our own consciousness. And IIT specifies these essential properties are information, integration, exclusion, and composition. And these are all. And then, from the essential properties, IIT hypothesizes the following about quantity and the quality of consciousness. So from phenomenology to the physical substrate, that's a way to go. And then hypotheses are like this. A system must generate information, must integrate information, and only a system having locally maximum phi generate consciousness, and the information structure of a system corresponds to the quality of consciousness. So the important message here is that information is essential. Information is a key. And how information is generated by physical elements or mechanical system does not matter for consciousness. So any kind of system can generate consciousness if it generates information and integrates information. That's a point of IIT. And IIT, in that sense, is very general theory. But here is a kind of huge jump, because IIT starts from our human consciousness, but IIT somehow generalized this to the everything. But yeah, I'll go back to this point in the later slides again. So here I explained about how to build a theory of consciousness. But the important step is, of course, test the hypothesis in experiments. If the experiments refute the predictions of IIT, we need to give up IIT, or we need to definitely improve some theoretical predictions, theoretical sort of assumptions, or anything to explain correctly the experiments. So this is very, of course, important step. So we need to again clarify some testable predictions based on our theory. That's a third step. So examples of testable predictions in experiments are like this. So about level of consciousness, integrated information should decrease during dreamless sleep or during anesthesia, meaning during loss of consciousness. And also about quality of consciousness,
subjective closeness between experiences should be isomorphic to closeness between information structures. And also the third one is about the places of consciousness. For example, this is very specific prediction, but for example, when consciousness is split brain patients, integrated information in the whole brain is larger than that in only the left or right brain, or something like this. These are the hypotheses that specifically need to be tested in experiments. So again, and also so far the direct test of IIT has not been yet done. Like direct test of these predictions has not been yet be done definitely. So there are, in a sense, no satisfactory supportive evidence for IIT at this point. But including me, people are trying to show these predictions or trying to test these predictions in experiments. It is a kind of study. So I'll just really briefly explain some of trials about the test of IIT. So about the hypothesis for level of consciousness, like integrated information should vary depending on the sort of various states of consciousness. Integrated information should be really low in coma, and also should be low in non-REM or maybe I should put maybe dreamless sleep, and also in the anesthetized state and the epileptic seizure or in vegetative state, persistent vegetative state, integrated information should be definitely low. And the integrated information should be high in wakefulness and also in REM sleep when we are dreaming, something like this. So we have to quantify integrated information in various states of consciousness and need to verify this prediction. So this attempt is starting, but again, there is no direct evidence for that. But Tononi's group themselves are, of course, trying to check this hypothesis. They have not yet actually quantified the phi quantity, but there is indirect evidence where that integrated information would probably decrease during loss of consciousness. So what they did in experiments is that they applied transmagnetic stimulus, TMS, to the brain, to the wakeful, to the brain, the wakefulness, and also the brain during sleep, and also brain during anesthesia, or in the brain in vegetative state. Then, what they found consistently among different loss of consciousness is that TMS stimulus, the evoked response by TMS, is prolonged or lasts longer than the evoked response during loss of consciousness. So here, the evoked response by TMS spreads over the brain, and this activity lasts longer. But if you apply TMS during non-REM sleep, then this evoked response remains at the spot of stimulation. It does not spread over the brain. And then the latency is shorter as well. So this means that there is effectively breakdown of cortical connectivity during loss of consciousness.
So we can guess that integrated information also probably decrease. But there is no direct evidence again. So let's skip this part. And about the hypothesis for the quality of consciousness. So what IIT hypothesizes is that information structure. This is just an information schematic of information structure evoked by, for example, this stimulus. And this information structure corresponds to quality of consciousness. So if even if there is even if the same stimulus is presented, but the information structures are different, then the quality are also different. And the similarity between information structure corresponds to similarity between subjective experiences. That's a hypothesis. And we tried to check this hypothesis. Yeah.
So here is just one direction to the other, right? So it's injective. So it's by isomorphism, you mean bijective?
Bijective.
But here you show only injective.
Yeah, sorry, This is no meaning, basically. This arrow actually doesn't mean.
So what do you mean here by isomorphism? Bijective or injective?
There is actually no strict mathematical definition here, but in words, the similar, if this information structures are similar, then the quality of experiences are also similar. And if that, for example, you can think of another mix or another information structure here, then if this and that are more different than this and that, also this relationship needs to hold in subjective experience.
So it's injective.
Injective, yeah.
I think you want to say if Korea is different, then X is different from other, right? I think it's true, right?
Sorry. Yeah.
You mentioned if a mix is different, then Korea is different, but his question is whether Korea is different.
Yeah. You can go from here.
Injective means only one direction, and bijective means two directions.
Yeah, completely.
Isomorphism normally means every change.
Yeah.
Every change on one type of representation induces a change on the other type, both ways. So but here you have an arrow only in one direction.
I see.
So it's not really clear, but you say isomorphism.
Yeah, you are completely right. Yeah.
Okay, thank you.
But this is again hypothesis. Yeah. So we try to test this hypothesis by using the human intracranial recording. And we sort of quantify the information structures induced by different stimuli. And also that even though the stimuli are the same, sometimes that the subjects see face, and this is actually used continuous flash suppressions, or the stimuli are sort of something masked. And sometimes subjects can consciously see faces, and sometimes cannot see the faces. And but we found that the information structure can explain this difference between the subjective experiences, not just external stimuli. Something like this. So we, but this is just yeah. Maybe I will skip this slide, but the point here is that we also experimentally trying to test this kind of isomorphism by using the human intracranial recording. But this is just a first attempt, and we need to improve this kind of experiment, and also the quantification of integrated information. So final one is that exclusion principle, and as there's a question whether the AIDS brain really actually generate higher information than the AIDS left or AIDS right brain would be one test for this exclusion principle. So AIDS whole brain need to generate higher integrated information than the AIDS left or AIDS right brain. That's probably one thing we need to test. And also, what I'm personally interested in the split brain case. So if IIT is right, if there is no corpus callosum between left and right brain, of course there should be two independent consciousness. But let's assume that we gradually strengthen the connections. And then what we should observe is that at some critical point where the Phi's order is reversed, then we should observe that the two independent consciousness sort of disappear and one consciousness emerge. So this kind of discontinuous sort of phase transition would occur if the strength of corpus callosum connection is gradually cut. So the question is that whether IIT accurately predicts the critical point of this phase transition phenomenon in split brain case. So this thing probably can be tested in experiments as well. And this is just a simulation. So this is just a really toy model, and this is not. It is really far from of course, the actual situation. But this just gives you idea. And we prepare that whole brain network constitutes of the consisting of left and right brain network. Then we control the strengths of corpus callosum connections, and then what we found is that this is the phi in each hemisphere, and this is the phi in both hemispheres. Then if we increase the strength of connection, the phi in both hemispheres gets larger than the phi in each hemisphere at some point. This is here is the phase transition point predicted by IIT. So we need to do a similar thing in actual data. So okay, so this is the whole summary of how to build a theory of consciousness. So as I said, step 0. First, we need to specify the problems to solve, and then from phenomenology, IIT specifies the essential properties of consciousness, and then derive the hypotheses from the essential properties and describe them by mass. So mass is really important to reduce or completely eliminate the ambiguity of the theory. So we can discuss uniquely or openly the meaning of the theory, what the theory means, based on mathematics. And then the important step is, of course, we need to test the hypothesis or predictions in neuroscientific experiments or in medical experiments or anything, or in psychophysics as well. So, based on these results, we of course, need to sometimes rectify the theory, or we need to completely give up the theory. That's, of course, very important step. So I personally is focusing on this step. And if the predictions are satisfactorily proven in experiments, we can do extra step, which is extrapolate these theoretical predictions to completely different system, like artificial intelligence or robots or something. So, as I said, IIT is general theory. Because that system in IIT does not only mean brain. It can be, any kind of system. So, just by using IIT, we can evaluate consciousness in artificial system, and we can predict whether this AI is conscious or not. So that I'll just briefly mention this one. So the people are, increasingly interested in AI because the AI has developed very much recently. And sort of natural question is that, whether AI has consciousness, consciousness. And usually, as an AI, what it can do is important. And only the function is important. For example, that whether AI can talk like humans or answer quizzes or can play Go or something like this. And the inside of AI does not matter, or how these functions are realized in the AI doesn't matter. We basically don't care much about this. But as in respect of consciousness, a function itself is not directly relevant to consciousness, according to IIT. But how the function is implemented. In other words, information structure is relevant. So we need to look at the inside. The inside is important for assessing consciousness. That's IIT's point. So, for example, that according to IIT, networks with same functionality could generate different consciousness. For example, that what we prepare here is that from the outside point of view, these two networks are safe because that input and output relationships are exactly the same. But network implementation are totally different. In the left-hand side, phi is large, but in the right-hand side, phi is 0 in the definition of IIT 3.05. So this kind of thing could happen. So the important thing here is that we need to look at the inside to assess artificial consciousness. So the famous Chinese room salt experiment can be, of course, discussed in this framework. Like in this salt experiment, probably many of you know, but inside the box, a human, there is a human, and there is a sort of magical book. And what this human does, what it needs to do is that to answer questions in Chinese. But this guy that doesn't know, or doesn't understand, doesn't speak Chinese, doesn't understand Chinese at all. And what this human does is that look at just sequences of characters, Chinese characters, and then look into the dictionary or the book. And this book contains the appropriate answers in Chinese. And then this guy can answer, just write down the answers in some paper. And this guy, give it this, paper to the outside guy, the guy outside. And then this, box can sort of talk or conversate, do the conversation with a human outside. And this guy basically, thinks that the box can understand what he says, and the box can understand the Chinese. But actually, inside the box, this guy doesn't understand anything. So in this case, actually, this function can be implemented, for example, by a purely feedforward network without any compositionality. So according to IIT, the box is basically unconscious in a sense. So function itself is not directly relevant to consciousness. Rather, inside of the system, informational structure of a system that realizes the function is important, and it determines the quality of consciousness. That's probably the final claim from IIT. So, as I said, that IIT is a general theory, but before we apply IIT to more general things, we of course need to, I think, test the theory in the experiments. But if IIT is proven to be successful in explaining consciousness in humans or maybe other animals, then it could be possible that the consciousness in any kind of system can be objectively quantified by analyzing the information structure in a unified manner. So we probably can quantify consciousness in a newborn baby, or in cats, or in robots, in the same framework. Okay, so let me summarize this. So this is the final slide. So I, of course, explained IIT a little bit in detail, but my main point here is that, again, not to, explain exactly IIT, but what I want you to do here is that to propose a common framework for how to build a theory of consciousness, and in particular mathematical theory of consciousness. So again, that in step 0, we need to specify problem to solve. I sometimes cannot know what kind of problems a particular theory tries to solve. So this determines the scope of the theory. And in the next step, need to specify essential properties of consciousness. This corresponds to theory's definition of consciousness. And if you follow each step, I think that we can clarify the differences, or we can probably come up with some experiment that can differentiate the theories, different theories of consciousness. So again, that the step 3 corresponds to testable predictions of the theory, and the step 4 corresponds to some supportive evidence of the theory, and the final step is that extrapolate that theoretical results to the artificial system, which corresponds to some potential ability of the theory. So this framework will be useful for characterizing the existing theories and clarifying differences. Also, this will be helpful for improving the theories or inventing a new one as well. So I think that, as I said in the beginning, I probably need to characterize all of the other theories based on this framework as far as I can. But maybe I need some helps from specialists from other theories, I think. But this is my future homework. Yeah. Thank you. That's all. Yeah.
My question is about the time delay of the system and the seal. So there are different the value of time delay in the line, right?
Yeah. You mean you are talking about the time delay when we compute the information?
Yes.
Yeah.
So some connection have one delay and another connection has different delay, right? So how so I wonder how to determine the tau of this theory.
Theory's principle is that this is a parameter, tau is a parameter, and we need to optimize tau based on the maximum. Like,
so, but you know, the consciousness is the phenomena of the moment.
Yeah.
We feel consciousness at the moment.
Yeah.
Moment by moment.
Yeah,
Right?
moment, but consciousness probably needs some amount of time, like let's say 100 milliseconds or so, for example. Then this scale should be determined by the principle of this maximization. So there could be other scales like 1 minute consciousness or 1 year consciousness. The possibility is there, but what actually happens is consciousness exists in a particular time scale. And I didn't talk about this time scale issue. I just talked about spatial optimization, like only the maximal one exists. But that's about the spatial things. But even in time, we need this maximization. And only the time scale that generates maximum pi exists as a consciousness. That's IIT's another hypothesis or claim. Yeah.
One of the questions is the different time delay in the in one system, right?
Yeah.
So probably there is different optimal time delay, and depending on the tau, possibly we find different complex.
Yeah.
Right.
Yeah. That's I think that a good point, and I think that you need to combine all things like temporal optimization and also kind of spatial optimization. So it's really complicated mathematics, but you need to do the both, and then the maximal one based on this combination of my sort of optimization.
Another question.
Yeah.
So it seems that even if we are looking at the same system, but the phi might differ just by changing the resolution of the.
Exactly.
Yeah. So my question is whether do you have any idea to compare such phi's that are calculated based on the different spatial resolution? Because so many clinical cases we have many ways of recording.
Yeah, that's another very good point, and it's of course related to the previous question. Again, that in theory, IIT proposes that we only look at the maximum one. Like we need to change the spatial resolution or anything. Like what is the state is very fundamental question. Like we tend to think that one neuron is one element in the system, and also that spikes, for example, is something determine the state of the neuron, for example. But of course, the neuron constitute of more microscopic structures like ion channels or anything. So these kind of things also can be considered as states, for example. And we need to search for appropriate states that is related to consciousness, directly related to consciousness. And this appropriate scale should correspond to the maximal phi, maximal one. So this scale should generate most integrated information. That's the hypothesis as well.
Thank you.
Yeah.
I'd like to go back to your last slide. Actually,
Yes.
it's about the methodology to create.
Yeah.
So usually,
Sorry.
what we do as scientists is, if we want to create a theory, first we look at other theories.
Yeah.
And so here, for instance, you say specify problems to solve.
Yeah.
But I mean, first is to know if there are any other solutions that have already been proposed to these problems. And then whatever theory you can come up, whether it's a mathematical one, whether it's consciousness related or not, you need to relate it to other theories in the field. So there are many theories of consciousness, and some of them are good, some of them are bad. But from the start, it has there is a need to compare the new theories, the new theory with the others, but also after when you test the hypothesis. So because you said you were interested in step 4, I'd like to know if you tried to see how much of your results comply with the IIT, but also with other theories.
That's a very, very good point. So this is, again, my point, because that I personally actually cannot exactly understand what other theories try to solve, or what other theories, how the other theories characterize consciousness, or how much this theory can say about consciousness. For example, the quantity, quality, or places. And if the other theories are described in the same framework, we can fairly sort of compare the predictions, and then we can come up more fruitful, experiments that can clarify the differences between the theories, and then I can say that the IITs, for example, beta or IITs, not good, or something like that, compared with other theories. So to do this, I think that we need this kind of framework, and this kind of common framework.
Okay, I understand the point. The thing is, IIT came long after many others. So I think it should have been step 0 for IIT to actually create that framework where the results and interpretations that would be made in IIT could be also compared and evaluated in other theories. So what you're asking now is the reverse. That is basically IIT went in one direction and expects everyone else to follow in that direction. I think it's step 0, and then this is very important. It's not about specifying problems. It's really finding common grounds with all other theories. And IIT really missed that very important point.
Oh,
so
really?
Now it would be nice to actually have some people working on that from the IIT perspective.
I think that we should. I don't want to say that everyone should follow the IIT's framework or anything. I think this framework is general and not just for IIT, I believe. And we can sort of, describe the other theories in this framework as well. So I just, maybe we should sort of clarify these things, these framework explicitly. Maybe people sort of implicitly assume, some framework when the theories are constructed. But this, as far as I know, I don't know that the common framework so far. This kind of common framework so far. And as you said that, yes, specify problems like I just did in this talk for IIT, like where is it? This one, right? I agree that this step is very important, right? And because that sometimes that I cannot know that whether how much some particular theory can answer these questions, for example, and also how different things the different theory can answer. Like maybe other theories can answer different things, right?
Actually, the main theories of consciousness address all three questions. So really, it's possible to do that. It's just that somehow on the way there was no feedback to this step, which was fundamental, and it has been completely overlooked. But yeah, all other theories, and you can pick any review on other theories, and they would tell you how that theories describes quantity or quality or the whereabouts of consciousness.
Is it explicit enough? Or?
Yeah, this is for example, for the global workspace.
Yeah.
That's very clear.
I see.
The quality and the places. Right?
I see.
And
Cool. But about places, is it clear enough?
It's about the
I mean,
global.
It's the global workspace. It's the name of the theory.
Yeah, but my point here is let's consider maybe global workspace is maybe a good example to discuss. Like given a arbitrary system, that where is consciousness based on global workspace theory? Like global workspace theory talks about brains, the places of consciousness in human brains. Right?
But you study split brain patients, so you do the same. And also, it's about global accessibility, right?
Global accessibility, yeah.
So you're using exactly something that describes the same principle.
Yeah.
That is, I think when you say integration is the fact that all the information can go somewhere to be used to do something. And I think here you could make the link very easily, but we don't see that in the literature of IIT, and it doesn't make any sense. I've been studying consciousness, and obviously I don't agree with everyone on the field, on the contrary, but every time I try to relate my findings, or at least my interpretation, with other theories, and I really would love to see that happening in the IIT field, and I don't see that. Why? You want to discuss the place? Well, global workspace theory discusses that. You want to discuss the quality, the higher order theory discusses that.
Yeah.
So it's easy to relate, really.
Yeah, it's difficult point is that the other theories are not written in mathematics actually. So for example that
predictive coding.
Predictive, yeah, that's one thing. But the global space theory, for example, global accessibility of information. What does that mean in mathematical terms?
We are scientists. I've been doing so many different things through my career that I don't know anymore if I'm an engineer, a psychologist, a neuroscientist. I don't know anymore. You have to do consciousness is a multidisciplinary problem. You have to tackle it from many angles. You cannot just go with mathematics. It's impossible to tackle a problem like that with just one angle. Impossible.
Of course, I don't restrict just one angle. But to compare the theoretical predictions, or to compare what the theory says, I think that we need mathematics to.
I agree. We need mathematics. I agree.
Yeah. If we want to talk about difference in theories with less ambiguity or without ambiguity, I think math is very useful too. Because of the global accessibility of information, I actually don't understand the meaning of this. And I cannot, for example, let's assume that you are given some arbitrary network, and then can you find the places where the information is globally accessible by some first principle? I think that from the literature, from the information existing literature, I cannot do this personally.
I think to describe all theories with all angles is going to take some time.
Yeah, of course,
I agree that mathematics, it's good to see some mathematics in there, but why it has to be exclusive? I don't understand.
No.
It is because it does no comparison between all these propositions compared to with the rest of the literature, and that's why it's exclusive. But actually, you could describe mathematically also the global workspace theory, or well, we have predictive coding. You can do that, but you have to make an effort as a scientist to connect your work with the rest of the literature.
I totally agree.
It's very important.
I totally agree. So sometimes of course some theories are not written in mathematics term, but we can of course compare even though there is no mathematics in some theories. We can do that to some extent. But to advance more beyond this, I think that probably mathematics is an important step. But I totally agree. So I should compare, for example, the IIT's predictions from based on the available information.
Okay, thank you very much. Let's continue discussion in this afternoon.